Hello everyone and welcome. In this video I'm going to explain binary search in the most simplified way possible. So let's get right into it. So imagine that you have this array right here and you want to search for a certain element. For example, let's make our target 15. So we want to know which index of the array holds the element 15. Now we could use an algorithm called linear search, and what this consists of is basically going through each element of the array individually and seeing if it is a target. So we would start here at the beginning, then we would go to the second element, it's not equal, we go to the next element, it's not equal, we go to the next, and so on until we find our target. And this is going to give us a time complexity of O of n, where n is the number of elements in the array, right? Because we're going to have to look, in the worst case, through every element of the array before we find our target. Now, for this small array that I have right here, this is just fine. However, if you have a large collection of data, this is probably not going to be the best option. And that's where binary search comes in. Now, in order to apply binary search, your array has to be sorted, right? If it is not sorted, you have to either sort it first or you can't apply binary search. Now, the core idea is that we're going to have here two variables. One is going to hold the minimum. This is going to start out at the first element, and the other one is going to hold the maximum, and this is going to start out at the end of the array. Then we're going to calculate the middle position between our minimum and our maximum, and in this case, it's going to be 11, right? Now we're going to check if 11 is greater than or smaller than our target. So our target is 15, and so 11 is smaller than 15. And since we know that our array is sorted, we know that the whole left side of the array here is not going to be our target, right? Because all of those elements are going to be smaller than 15. So we can automatically cut this side out of the array, right? And now we're going to move here our indexes. We're going to set the minimum to be right there, which is going to be mid plus 1 if you really think about it. And then the new mid is going to be the middle position between minimum and max, which is going to be 20. Now, is 20 greater than 15? Yes, right? So the whole right side of the array, all of the elements that are after 20 can be cut out, right? Because none of those elements is going to be our target. So we're going to delete the right side of the array like so. And now we have found our target, which is the only index that is left, which is going to be right here, 15. And this is how you apply binary search. Essentially, since the array is sorted, you're going to start out at the middle. If the element is greater, you can cut out the left side of the array. If it is smaller, you can cut out the right side of the array. And then eventually you're going to get to your target. And this is going to give us a complexity of O of log of n, which is much better than O of n for large collections of data. And keep in mind that this logarithm is of base 2 since we're dividing the array in each iteration. Now, I know a lot of people have trouble grasping this concept, so I would encourage you to think backwards, right? Imagine that you're multiplying each time by 2. So you have 2 by 2 by 2 by 2 by 2, and so on. And this is going to give us a power of 2, right? 2 to the power of n. Now, if you do the opposite and instead divide, you're going to have some random number, n divided by 2, divided by 2, divided by 2. And so this is going to give us a logarithm of base 2. So I hope that was easy to understand. And now let's get into the code implementation of this algorithm. All right, so let's get right into it. What I have here is a binary search function. This is going to take in our array, its size, and the element we're looking for. And this is also going to return to us an integer, which is going to be the index of that element in the array. So the first thing I'm going to do here is create a couple of variables, which is going to be the indexes. So our min is going to start out at the first element of the array. Our maximum is going to start out at the last element of the array. And then our mid is going to be the mid position between the minimum and the maximum. Now we're going to apply this algorithm a couple of times, and the condition for that is while our min is smaller than or equal to our max. So essentially, if our minimum hasn't surpassed our max, then I'm going to say that the mid is going to be our min plus our max divided by 2. So we're going to get the middle position between the minimum and the maximum. Now in here, we're going to have a couple conditions. So I'm going to say if the array at mid is equal to our target. So essentially, if we have found our target in the middle position, then we're just going to return mid, which is the index of our target. Now, else if the array at mid is smaller than our target, then this means that the left side of the array, we can just throw it out, right? Because the middle is smaller than the target, and so the target needs to be in the right side of the array. And what this means is that our minimum is going to change. And we're going to say that the minimum is going to be mid plus 1, like so. So this is going to cut out the left side of the array. And otherwise, then that means the opposite, right? So the array at mid is going to be greater than the target. And so what this means is that the maximum is going to be our mid minus 1. So we're basically going to cut out the right side of the array, and we're only left with, well, the left side of the array, right? Now, if none of these conditions are true, if we haven't returned our index, and if our minimum isn't smaller than or equal to our max, then that means we haven't found our element. We're just going to return minus 1 like so. All right, and this is our algorithm. I'm going to comment this line out. This is basically calling the binary search algorithm with our array. Its size is 7, and we're going to look for the element 6 here. Now, I'm going to run this code, and this should hopefully give us 3, right? All right, and there we go. So 6 is here at the position 3. Now, if I say, for example, 1, if I run this code, this is going to give me 0. Then if I say 11, it's the last element, this is going to give me 6. And if I say an element that doesn't exist, for example, 14, that's going to give us minus 1 because this element doesn't exist. All right, so that is the binary search algorithm. I hope this video was easy to understand. If it was valuable to you, please like and subscribe to support the channel. Thank you so much, and I'll see you in the next one.